Hi and welcome to the first of 4 videos for section 3.2. This is a longer section, obviously, by the 4 videos for this. We're going to be doing some graphing now of polynomials. And so the videos are going to kind of break it down into figuring out bits and pieces of the polynomial, how that has an effect on the graph, so that once we sort of add them all together at the very end, it allows us to graph these polynomials without having to plug numbers in. So, as I told you guys, if it's the final exam or even if it's the in-class exam and you just blank and you can't remember how to go through these steps, you can always plug numbers in. It's just that it's going to take you quite a bit of time versus these steps I'm going to show you, which will simplify the process. So for section 3.2, this is polynomial functions. And graphs. So in 3.1 we looked at the quadratic function, just a specific type. X squared is going to be a parabola pointing up or down. Polynomial functions means that it could be x of any degree. So a polynomial function is of the form p of x, so we say p as for polynomial, is equal to a of n, x to the nth power, plus a n minus 1, these are our coefficients, x to the n minus 1 power, plus this keeps going, n minus 2, n minus 3, n minus 4, etc., until eventually we get to x to the first power, and then a0, x to the 0 power, which is going to be what? Anything to the 0 power is just 1, so that's our constant at the end. And again, these a, n values are the coefficients of the x variable, or y variable, or whatever variable is in this polynomial. Coefficients. One thing about the graph of a polynomial. So if you are tasked with sketching a polynomial, one thing you have to know is that a graph of a polynomial is continuous. And what that means is that there's no breaks, corners, or cusps. So for example, the thing to remember is that, or an easy way to remember this, I guess is a better way to say it, is if you're graphing a polynomial, your pen or pencil just keeps moving. It never stops, it never changes direction, anything like that. So it's just a continuous up, down, left, right, whatever it might be, comes up, comes down, etc. That's the graph of some polynomial. I never had to pick up my pen or stop it. So I couldn't have something like this and say that's a graph of a polynomial because there's the break in there. And then corners and cusps, so that means you'd never have something that looks like this. There's that corner. As I was drawing it, I had to stop and then start again. It's not a continuous motion. So this one, polynomial. These two, not. No breaks, no corners or points, anything like that. So that's the one idea to remember about it. Now we'll start delving into, if I'm given a polynomial, how can I figure out some information about the function or the polynomial function so that I can sketch it. The first thing is what we call end behavior. So this is asking, as x goes to negative infinity, so coming way to the left, what happens to this graph? Is it going up towards positive infinity? Is it coming down towards negative infinity? And similarly, as x is going to positive infinity, does the graph go to positive infinity or negative infinity? So, and behavior in turn in words says what happens as x becomes large in either the positive or negative direction. So again, as it goes towards negative infinity, what happens? As it goes to positive infinity, what happens? Well, let's think back. If I have y equals x squared, what does this look like as a graph? Well, it's a parabola, right? So in this case, what I would say is that y goes to what? So as x is going towards negative infinity, y is going to positive infinity. So y goes to positive infinity as x goes to negative infinity. And what else? Well, as x is going to positive infinity, y is still going to positive infinity. So y still goes to positive infinity as x goes to positive infinity. So as x goes way to the left, y is going to positive infinity. As x goes way to the right, y is going to positive infinity. What about the graph of y equals x to the third? So remember what this one looks like. This looks like that snake. It starts in the upper right, comes way down to the upper left. So y goes to where as x goes to negative infinity, and y goes to where as x goes to positive infinity. So as x goes to negative infinity, as I keep coming to the left, what happens to y? It goes to negative infinity. And how about as x goes to positive infinity? So as x keeps going to the right, y is going to positive infinity. So this is going to hold true no matter what our powers are. If it's x to the fourth, or x to the sixth, or x to the eighth, etc., etc. If it's an even degree, and when I erase that polynomial, the n is the highest number in the polynomial. That's our degree of the polynomial. So if the degree is even, it's always going to be going up to the left, up to the right. If our degree is odd, so x to the third, x to the fifth, x to the seventh, etc., it's always going to be going down to the left and up to the right. So let's sort of build a little chart of that, and I would highly recommend putting this on your cheat sheet so that as you have to sketch these, you can reference back to it. So end behavior is determined by the highest degree, and again, that's just the largest exponent. So whatever the biggest exponent is on our polynomial, that's the highest degree. So, by the highest degree coefficient. So if it's an odd degree, so again, x to the third, x to the fifth, x to the seventh. If the coefficient is positive, then our graph, so this is basically, so i.e. 3x to the third. So the coefficient of x to the third, the degree is odd, the coefficient is positive, so it's going to have this shape here. So it's going to end up over here, and it's going to end up headed down towards the left here, and in between, who knows what happens? I don't know. We'll figure that out later. But it's always going to be headed down to the left and up to the right, just as our base x to the third graph. If the coefficient is negative, so here the coefficient was positive, if the coefficient's negative, so for example, negative 3x to the third. Well, we know from when we were doing transformations of graphs, if we have a negative a value, what happens? It reflects it. So now, instead of going down to the left, up to the right, it's going to flip this thing, so it means what? It's starting up here, it's ending down here, and again, who knows what happens in between, but what I know is that the end behavior, the left and right sides of the graph, have this formation. So that's when the coefficient is odd, when the degree is odd. So odd degree. When it's an even degree polynomial, so x squared, x to the fourth, x to the sixth, etc. If my coefficient is positive, well, that was like what? That's like an x squared graph, which means it's headed up to the left here, it comes down and then heads up to the right. And so again, i.e., let's say 4x squared. So it's going to have some sort of shape. I don't know what happens in between here, but I know the end behavior, the ends of this graph are going up to the left and up to the right. So this is positive coefficient. If it's a negative coefficient, so i.e., let's say negative 2x squared. So because it's even, that has that parabola shape, but the negative coefficient flips it. So now I'm headed down to the left and I'm headed down to the right. And again, who knows what happens in between here. But what I know is that it's pointing down on both ends. So if you need to pause to copy any of that, go ahead. I'm going to erase this, give you guys an example here. So determine the end behavior of the polynomial negative 2x to the fourth plus 5x to the third plus 4x minus 7. So I have to first determine the highest degree. That's what? That's x to the fourth. So this is really the only piece I'm concerned with in terms of the end behavior. I don't care about any of this. It can be anything. It doesn't matter. It has zero effect on the end behavior. This is the only one I'm concerned with. So I know what? It's an even one. That tells me, okay, even is like the parabola, but because of the negative 2, that's flipping it. So I know it's going this way and this way. And again, who knows what's going on in the middle here? I'm not really concerned about that. My end behavior looks like this. So if you're doing this on an exam, that's good enough if you're like, okay, here's my end behavior. If the homework is asking you y goes to infinity or negative infinity, etc., how would we write it here? Well, as x going to negative infinity, y is going what? Y is also going towards negative infinity. And as x goes to positive infinity, y is doing what? Y is still going towards negative infinity. So as x goes to the left and right, y is going to negative infinity. One more example, and that'll wrap up video 1. So again, let's determine the end behavior. Of the following. P of x is equal to 3x to the 5th minus 5x to the 3rd plus 2x. So, first make sure it's ordered descending order, biggest to smallest. It is. So then that means all I need to worry about in terms of end behavior is this guy here. It's what? It's an odd degree polynomial. So that's like my x to the 3rd graph. And the coefficient is positive. So that's exactly like my x to the 3rd that starts up here, snakes through and comes down here. What happens in between here? I have no idea. Doesn't really matter. That has nothing to do with the bearing on the end behavior, but that's what it looks like. So again, in terms of the verbiage, so as x goes to negative infinity, y is going to negative infinity. And as x goes to positive infinity, y also goes to positive infinity. So again, I'm less concerned with this wording, more concerned or mainly concerned with, do you know which way the tails of these graphs are going, the end behavior of the graph? So come on back and we'll look at video 2 for section 3.2.